investors. We're looking at another portfolio optimization kit in Python. So we're looking today at the mean risk for Skfolio optimization, which is one of the main modules you can use in Python for portfolio optimization. You could check out my other video, where we used IBM's Qiskit for quantum portfolio optimization. I just did it on a very small portfolio for that video, only 4 stocks here. I'm looking at a few more tickers, as you can see here, and loading that into our terminal here. I'm using VS Code, obviously. So we're looking at data until 2024. I'm just going to model out the data and picture out the data from 2023 to 2024, so you can just get an idea of what this portfolio optimizer can do for us. So yeah, constructed the code and ran it, and this takes some work so to get this code to run. But once we got the code to run, so the results are down in the terminal. We see down here that optimized portfolio weights. It gives us how to weight each of our tickers in our portfolio. The sum of the weights is going to be 1. So this is the optimized weights. And we're going to look at optimized weights versus equal weights and then compare the portfolio performance from 2023 to 2024. I know I loaded more data. The more data you have, the better the optimization usually. So over that time period. So I did some debugging, had some issues. So I did some debugging earlier. And so what we see is for the annualized mean return for the optimized portfolio is 61.89%, and volatility is 35%. Sharp ratio 1.76. Usually the higher sharp ratio is better. Here's the equally weighted portfolio performance. Mean return you see is far lower. Volatility is lower, so I'm guessing there's less risk in this equally weighted portfolio, since our lower volatility means you have less higher ups and lower lows than optimized portfolio. And the Sharpe ratio is slightly higher. But when we see the cumulative returns, so we're plotting cumulative returns here, we're just going from the end of 2024 and beginning, just as an example, July of 2023. We see that there's a pretty big outperformance in terms of the optimized portfolio and the manually for the equal weighted portfolio when we calculated that manually using NumPy. So obviously the optimized portfolio gives us much better returns in the long run. So what basically this is doing is it's telling us the weights, which weights we should allocate to our portfolio given the tickers over a certain time period. So yeah, if you want to extrapolate this out, you could have a larger data set and have expected returns. And the expected returns could be theoretically higher in an optimized portfolio. Let's say you're given 20 years worth of data, and here we're looking maybe at blue chip type stocks or something like that. Even though Tesla is not really blue chip, but for a good time period, we're looking at this. So yeah, this would be just the cumulative returns, and we see the optimized portfolio very much outperforms the equal weighted portfolio. And you could just see that there's less volatility in this graph, in the orange graph as compared to the purple graph. Purple graph has a lot more sharp declines and sharp rises up, but overall it's outperforming. So, this I just wanted to go over a quick example of how one again can use portfolio optimization to tell you what stocks, how to weight your portfolio, and what stocks to insert in your portfolio, or or delete from your portfolio. That is, to kind of optimize your own portfolio's performance. Usually, the higher Sharpe ratio is better. Here we see they're about the same Sharpe ratio. So obviously the optimized portfolio outperformed the equal eight per portfolio. So yeah, this is just a quick example. I hope to explore more different types of. So this would be a convex. This is a convex problem. So I hope to explore more different algorithms one could use for non-convex problems and portfolio problems, and using Python and the tools that are available to me, which are mainly free tools. That for all these packages I use are freely available through Python, and you can download the modules yourself. And usually my data sets are pretty small because I don't have the licenses for the commercial version of what would need to be done for these types of sets. So in any case, just giving you a quick example here. Just wanted to go over this with you guys. I'll come up with another example soon, and let me know if you want to see anything in particular, any particular portfolios. I could certainly backtest and or compare different algorithms against different same portfolio to kind of see which algorithm would work best for which portfolio, and which stocks in that portfolio we should have. So there's a lot of studies you can do, a lot of case studies you could do in terms of portfolio performance and analyzing data using Python, and this is Skfolio module package SDK. So yeah, hope you enjoyed this. As always, let the markets be with you, and take care.